Hello there and welcome to this session. My name is Germán Viscuso and I work as an Alexa technical evangelist at Amazon, and I am very excited to share with you today a talk dedicated to Alexa skill developers. During the next few minutes, I will show you how to create and maintain Alexa skills by just using Visual Studio Code and JavaScript, and I think you are really gonna like it if you're a code-first skill developer. This is all made possible thanks to a set of new tools and frameworks announced recently that we specifically designed to make your developer life easier. By the end of this talk, you'll have a pretty good idea on how to create, expand, and debug an Alexa skill just using the IDE, in our case Visual Studio Code, some JavaScript, and a few standard tools such as Git and npm. If you're an Alexa skill developer that is not afraid of code, I think you're definitely going to enjoy this. I know I am, so let's dig right in. First, let's start with the one prerequisite that you need to follow this session, the Visual Studio Code IDE. I'm assuming you have installed it already, otherwise you should head to code.visualstudio.com and install it. So how do we enable the IDE for Alexa skill development? And the answer is simple, you just need to install our extension, the Alexa Skills Toolkit for VS Code, now in version 2.0, that includes several enhancements, such as no dependency on the ACLI or our command line interface, a new workspace with access to most typical skill development lifecycle operations. It works nicely with Alexa hosted skills, and I'll tell you more about them later. It supports local debugging and testing, and it now has the ability to preview APL documents. Now, let me quickly show you how to install the toolkit. Here I just go to the extension sections in the IDE and search for Alexa, and I get the toolkit as the first result. So now I just click on install, and as you can see, we now have an Alexa logo in the activity bar on the left. I click on it and then on the sign in button, and the web browser pops up, and I click on allow to link it to my Amazon developer account. And that's it. You probably have an Amazon developer account already, but just in case, you can get one for free at developer.amazon.com. Now everything is ready for us to start working on our skill. So I'll show you how to create one, and we'll choose a type called Alexa hosted skill. But why use an Alexa hosted skill? What is that? Well, it's very straightforward. They provide everything in one package, including the hosting of backend code, which is used for providing skill responses. You don't have to do any hosting yourself. We take care of that. And on top of this, we fully support them in every single tool that we put out there. And recently we have upgraded them in many ways. For example, they now deploy in under 20 seconds. They also place the AWS Lambda backend in multiple regions automatically, so your skill is always coming back to the user in the fastest way possible when it comes to location. And finally, they provide tons of templates for you to get started. So let's create one with the toolkit. As you can see on the screen, when we click on the Alexa button on the activity bar on the left, we have access to a dedicated workspace. I have options to create skills, to import them, and to manage developer profiles. And once we create a skill, you'll see a whole set of extra options. I'm going to go ahead and click on Create New Skill. I'm going to name the skill Hello World and leave English US as is. Then I will select the directory where to put the local files of the skill. Now I'll click on the Create button, and this will take about a minute or so, so this is what's going on. An Alexa hosted skill is being provisioned right now in the cloud using the Alexa service. Both front-end and back-end space is being assigned to you and being filled with the details of the Hello World template, but nothing is happening on your local machine yet. Now, when you see the skills details received and skill package created messages, the toolkit is cloning the skill to your local machine so you can work on it. So we're done. Let's take a look at the voice interaction model that comes with the Hello World template. The first thing I'm going to show you is how to change the invocation name that you can see in the voice interaction model on line 4 on the screen. As it has been set to change me by default, and it would be awkward to test our skill by saying Alexa open change me. But what is a voice interaction model? Let's take a step back and take a quick look at the structure of an Alexa skill. A custom Alexa skill consists of two basic parts: the voice interaction model, also known as the front end of the skill, and the programming logic or back end. The voice interaction part defines the structure of the spoken elements that the skill needs to support, such as how to be invoked and which phrases or in the lingo utterances to handle. The voice interaction model will route utterance to specific intents or intentions of the user that you as a developer need to define in your skill. Once an intent is triggered, the backend will get a request with all the details, and it's up to you to define the programming logic that will handle the request and provide an answer, such as the typical case where Alexa is saying something back to the user. Together then, these two components take care of all requests and responses in your skill. When you use Alexa hosted skills, we host both parts for you. The front end sits in the Alexa service and the backend in an AWS Lambda function, which you can use with no charge up to the limits of the free tier of AWS. But you can also create a self-hosted skill where the backend is placed on any service that supports HTTPS. For example, it could be hosted in an AWS Lambda function in your personal AWS account. I hope it's clear to you by now that skills are not deployed to Alexa-enabled devices directly, but rather deployed to the cloud. So once your skill is live, it has the potential to quickly reach all Alexa-enabled devices out there. So when you take a look at the local files of a skill, such as the one we just created, you'll see something like this, with the skill package directory containing the voice interaction models and the skill manifest, which roughly represent your front end. Then you'll see a Lambda folder with the backend code, usually an AWS Lambda function, in JavaScript, Python, or Java, where we have SDKs. But things are a little bit more complex, with a structure that includes project configuration, such as deploy details, extra elements in the skill package, such as in-skill purchasing products, and even a separate directory for defining skill infrastructure, such as YAML files with CloudFormation stacks. Most often your structure will look more like this, and if you support more than one language in your skill, you will see multiple voice interaction models, not only the one for English US. So the typical internationalized skill will have multiple interaction models in different languages, but still one backend. For example, one AWS Lambda function, where you'll have to detect the language in the incoming request in order to send a response in the right language. So back to the task at hand, I will change the invocation name from change me to hello world in my model. Then I will go to the command line and do a git status, because all Alexa hosted skills come in a git repository. So I will just add the change files and commit them for now. If I do a git push, the skill gets deployed, but I just want you to see next how to do it from the user interface. But it basically comes down to the same operation. By the way, you can also do git operations from the activity bar, third icon from the top, where you have a nice UI for git. Now, when I click on the Alexa icon, I can see several options offered by the toolkit for this skill. I will click on deploy skill and then on deploy and build. So as I said, this is basically doing a git push to the master branch, and I will tell you more about branches and stages in Alexa hosted skills in a couple of minutes. This will take just seconds. And so we're done. The changes were deployed successfully. But how is an Alexa hosted skill related to Git branches, and how is that related to my skill being in a development stage or a production stage? Let's take a closer look. First, when we are developing an Alexa hosted skill, we are working on the master branch in the included Git repo, and that corresponds to the development stage of the skill. Every time we deploy to this stage, we deploy both front-end and back-end. We can test it out and it will basically run perfectly, but only our developer account will be able to use it, either on the simulator or on a physical Alexa-enabled device. When we are satisfied with how our skill works, we would submit the skill for publication, which will go through a certification process. If approved, the skill goes live and we will have access to a Git branch called prod that corresponds to the live stage of the skill. From a developer point of view, we now have access to two skills, the one in development and the one live. In the typical development cycle, we would continue to work on the development stage until we are ready to submit for certification again. But there's a fundamental difference between the two stages. We can only submit changes to the backend of the live stage. Changes to the front end will be ignored. If you want to do that, you will have to go through the certification cycle that I just explained. If you think about it, it makes sense. Otherwise, you will be able to change the front end of live skills on the fly. Let's try out the skill now we change the invocation name. Enter the simulator. The simulator is a virtual Alexa device with features that make it ideal for testing skills. It's available in the developer console at developer.amazon.com/Alexa, but now it's also embedded in Visual Studio Code via the Toolkit. In the developer console, you can talk to the simulator or just type in your utterances, but the embedded version is limited to typing for now. One of the things that might help you go faster is that when you're using the simulator, you can skip saying the wake word, since you will be waking up the device when pressing on a button basically. One of the things I like the most is that you can take your time to send the next utterance and remain in session. This is something you can use to make debugging of the skill requests and responses easier. And you can check these requests and responses in the simulator as they are plain JSON. On top of that, the simulator incorporates a functional APL rendering engine, so you can see and interact with your APL from it. Having said all this, you can also test on a real device, as long as you use the same Amazon developer account on it to get a feeling of the real deal. So let's take a look at how to access and use the embedded simulator. Here I go to the test skills section, then open simulator, and then I enable the skill by setting it to the development stage. You won't be able to open the skill until you enable it. So I will send an utterance here to open the skill. There's no need to start with Alexa, as you can see. Let's wait for it. And I get a welcome from the skill, and I can see the JSON in and the JSON out. Then I just sent a hello utterance while still in the session, and I got a proper response, hello world. We have just processed first a launch request and then a hello intent. But what did really happen behind the curtains? Let's take a closer look. Here you can see the Alexa service in the center, which is in the cloud and always learning. It applies several machine learning processes to understand and generate speech. On the left, you can see the customer. On top, the Alexa enabled device. And below, we have visual elements that can be shown in multimodal devices. Finally, on the right, there's a representation of your backend, which in our Hello World project takes the form of an AWS Lambda function. The customer initiates the interaction by saying the wake word, for example Alexa, which is detected by the device. Right after that, the device streams the audio to the Alexa service for processing. Now, with each phrase or utterance issued by the customer, the Alexa service applies a process called Automated Speech Recognition, or ASR for short, to translate the speech to text. After that, another process kicks in called Natural Language Understanding, or NLU, that tries to interpret or extract the meaning from what the user is saying. Ultimately, the goal of NLU is to understand the user's intention or intent. Once an intent is identified, this information is passed to your backend as a stateless JSON request. So your backend gets a request with enough information to determine what to do. You won't receive audio or a raw text transcription of what the user just said. Typically, you would implement intent handlers as functions that, based on information on the request, craft a proper JSON-based response quickly. The response from your backend is then sent back to the Alexa service and can include a text response, streaming audio and visual elements, among others. Our SDKs are very helpful here to allow you to process incoming requests and create outgoing responses without going into JSON parsing. If you send text that Alexa should read, another machine learning-based process called text-to-speech, or TTS, is performed to convert the text into audio. And that is what the customer will hear. And that's it in a nutshell. I hope it's now clear what's going on when we say hello to our Hello World skill. Before coming back to the project, let's also take a look at how a customer interacts with custom skills. As I said, the wake word initiates the interaction and is configurable based on a set of predefined options. For example, if you're a Star Trek fan, you can change the wake word Alexa to computer. Then there's a launch phrase that signals that the customer wants to open a custom skill. Alexa needs to understand which skill the customer wants to address, so we have several options besides open, such as begin, launch, etc. The invocation name is set by you as a developer, and if you make it memorable, it will be easy for the customers to remember how to invoke your skill. Remember that every time a skill is open, in this way your backend will get the launch request. Customers can also pass more information after the invocation name using a combination of open with and, like open hello world and say hi, for example. The same effect can be achieved by using other combinations, as you can see above, that include the verb ask and tell. In this case, the launch request will be bypassed and an intent will be triggered directly. As expected, any sample utterance that we specify in the voice interaction model and their specific intent will trigger that intent. The nice thing is that you don't have to add all possible ways in which a customer can show an intention, since the sample utterances are used as training material to define a mapping that is flexible, also including similar phrases that you did not specify. So it's important that you provide a rich set of sample utterances in each intent. The more training material, the better. And that you don't add similar sample utterances across different intents, which is ultimately something that will confuse the system. So we don't need to leave the IDE to test our skills now. Let's try to do the same with the voice interaction models. Typically, an Alexa skill developer creates the voice interaction model in the developer console. But when the developer modifies the model in the cloud, then it goes out of sync with the codebase in the local machine, and that requires a manual sync later. Because of that, we now offer developers the possibility to generate the voice interaction models from JavaScript code, one of the many features introduced by the SDK controls framework. In a minute, I will show you how to generate a simple model, the one we use in Hello World, but you can keep exploring the model generator since it also supports advanced elements usually found in complex skills. The Hello World model is simple enough so we can create it from scratch. But if you want to build on top of an existing model, you can also fit it in to keep all of its elements. This is particularly useful for SDK controls, which are reusable components provided by this new framework that will automatically generate model support for you, hence the need for pass-through functionality. So let's open package.json inside the Lambda directory of the project and add the dependency for the SDK controls framework. First, I bump up the version of our main SDK dependencies, since the ones in the Hello World template are a little bit outdated. Now I add the dependency to SDK controls, which includes the model generation functionality, among many others. Let's create an extra JavaScript file in the Lambda directory, which I call buildModel.js, to put the model generation code. Let me paste the code in and quickly add a script in package.json to generate the voice interaction model programmatically. I will get back to the model generation code in a sec. Here you can see that we use the class control interaction model generator to set the invocation name, the standard intents, and a custom hello intent with all the utterances that we want to support. This is basically mimicking what the original model in the Hello World template is doing. In the last line, we write the JSON output to the location that hosts our models, and we override the existing file, so we are generating it from scratch. Now, every time I want to generate the voice interaction model, for example before a deployment, I can just do npm run build model. For small models like this one, this is as simple as it gets. We don't deal with JSON, which is the native format of voice interaction models. We now deal with JavaScript. If you're interested in many features that the SDK controls framework provides beyond voice interaction model generation, you can go to this link for more information. Let's now go visual or multimodal. For that, we can use the Alexa Presentation Language, or APL for short, that allows you to create visual experiences for devices that support them. What is really interesting about APL is that besides visuals that include animations, graphics, videos, and more, it also provides a touch interface that allows users to interact with your skills. To do this, you need to get familiar with the concept of APL document and how they are rendered by sending directives with the skill response. Let's create a very simple APL document that shows Hello World on devices with a screen every time the skill sends an audio response saying Hello World. I click on the Alexa icon and choose Alexa Presentation Language, then Create, and then I select Short Text Sample. I get a template APL document with a background image and some text on top. I can select the different viewport profiles here, so I choose the one for the echo spot so you can better preview the document. Now I will click on Preview on the left so I also get access to the data source file. In it, I change the text from Welcome to the Daily Cheese to Hello World. And as you can see, the preview changes in real time. So now I want to visualize this APL document, and for that I will move it together with the data source files to the Lambda directory so it's accessible from the Lambda function. Then, and most importantly, I need to add a directive of type Alexa Presentation APL render document to the skill response of hello intent. The skill response then, besides instructing Alexa to say hello world, is attaching an APL document that will be rendered on multimodal devices. Before deploying the skill, we need to modify the skill manifest, the skill.json, and add the APL interface. Otherwise, if you try this right now, it won't work. Now let's stage all the changes and commit. I'll add a commit message here, and we are all set now. Now we're ready to deploy and test. So let's go ahead, access the Toolkit deployment option and click on Deploy and Build. This will take just a few seconds, so bear with me. Remember, this is basically doing a git push behind the curtains and monitoring the status. There you go. The skill was deployed successfully, so now we can test it out. Let's open the embedded simulator just like before. Now we ask Alexa to open the skill here in this text field. Click on Send. Wait a little bit. And now we say hello. Send that hello. As you can see, we got the hello world back, but if we click on device preview, there's our APL. Nice, we got it. Let's take this up a notch now that we're focusing on APL and code. We've developed APL because we think visual experiences are an important component of engaging with skills. So we want to make it easier for as many developers as possible to get started with APL, particularly for those that have web development experience. That's why we created this new experimental library called JSX for APL, which enables you to write APL documents using JSX and React. For those who aren't familiar with JSX and React, it's a popular framework typically used to create dynamic web UIs using JavaScript and XML-like code that is simple and elegant. With JSX for APL, we've taken some of these ideas to create a code-first approach for writing APL. This enables those with JSX experience to leverage their existing knowledge to add visual experiences to skills. And just like with JSX and React, the components you write will be reusable and shareable. Let me show you the code of a simple template to render an image and some text. First, you'll notice that every JSX for APL template is simply a React component. So if you're familiar with React, you'll use many of the same APIs and patterns here, including having a render function for your component. Next, JSX for APL provides a complete library of predefined APL components that you can use, such as Alexa header, text, image, and more. So here we use the Alexa header component to provide a header title for our view, a text component to lay out the title for a fruit, and an image component to include a visual representation of the fruit. In it, we just provide the URL of an image. And this is the visual representation of the code I showed you before. However, we can take advantage of more advanced features provided by JSX for APL. So, just like JSX and React, you can use many of the same composition features by creating your own APL components and reuse them. For example, we've refactored our fruit template from before into fruit item. So now we can actually have a list of fruits and iterate over them programmatically in JavaScript. So with minimum effort, we can now render a sequence of fruit items. With JSX for APL, it's now possible to easily create and add complex visual experiences using familiar patterns and libraries. And of course, JSX for APL works with the AS SDK and the controls framework. Head over to alexa.design/JSX for APL if you want to learn more. Now let's go back to our Hello World project and add something very important: regression test support. Using the simulator, we can test a live skill, and in a minute I will show you how to leverage it to debug your skill. But sometimes you want to run a battery of automated regression tests by just probing your code systematically to see how it responds. Regression tests, if comprehensive, will help you avoid unwanted errors while you evolve your skill and will help you validate key scenarios quickly. We can create them using familiar frameworks like Mocha and Chai, but also leverage special support introduced by the controls framework. Let's go hands-on and start by adding the necessary dependencies to our project. So I go back to package.json in the Lambda directory where we list our backend code dependencies, and I will start by modifying the placeholder test script with a line that runs the tests via Mocha. Then I'll just add the development dependencies for Chai and Mocha. Since I added SDK controls here before to get the model generation functionality, then I already have that special support for tests that I will show you in a minute. Let's now edit index.js to export the launch request handler because that's the one I will use in my example test. I basically want to test if the skill provides a proper response when launched, and I will need access to this handler for that. Now I will create a test directory inside Lambda and a test file inside it, which I will name test1.js. I will now paste the code for my test here and pause to explain it in detail. Here in the test, a skill tester is initialized with a reference to the exported launch request handler. The skill tester can run a turn through the skill code and validate that a particular prompt is produced. Skill tester test turn takes 3 parameters. The first is the user utterance, which is left blank when testing a launch request. The second parameter is a control input that will be the input for the turn. The test input class has utilities to create the most common kinds of inputs such as intent request, launch request, and APL events. The third parameter is the prompt that the skill is expected to produce. Here we are looking for a specific output that should match what we are sending as a response from the backend code. Check out the line 11. After testing a turn, further validations can be made by inspecting various objects. For example, in line 12, we check if the session remains open. So now I will install the extra dependencies by going to the Lambda directory and doing an npm install. Let's wait for all dependencies to install. Okay, now I'll run the test doing npm test. And as you can see, we have a passing test. You can make it fail by changing the welcome message either in the skill or in the test. So let's cover the last topic and one of the most powerful features of the toolkit, local debugging. Local debugging comes with multiple advantages, with the top one being that you can set breakpoints and use the native debugger in VS Code. And unlike previous solutions, you don't have to set up anything on your side to channel the connection to your machine. No tunnels needed and no endpoint changes needed. It all comes down to adding one extra NPM module to your project. But there are just a few limitations that you need to be aware of. You can't route a live backend to your local machine using this solution. The debugger works only on the development stage of your skill. And a developer can only have one debugging session at once, which in most cases is fine. So let's go ahead and add local debugging to our Hello World project. The first thing we need to do is add the development dependency for the NPM module that provides local debugging. Now we go to the Visual Studio Code debugger in the activity bar and create a launch configuration file for our project. I choose Node.js, but I get rid of that configuration and click on the Add Configuration button. As you can see, we offer you predefined options for Node.js and Python. So I choose Ask Alexa Skills Debugger and that's it. The parameters will be filled in automatically, and now I have a button to debug Alexa skills. Let's take the debugger for a spin. First, let's set a breakpoint in the launch request handler on lambda index.js. Now let's start the debugger and take a peek at the output in the debug console. As you can see, the sessions only last for 1 hour and are limited to one developer and one session at a time. Let's go ahead and see if we can trigger the breakpoint by opening the skill from the embedded simulator. Let's send again and open Hello World. And voila, we just triggered our breakpoint and can now debug line by line with access to the values of variables in our backend code. So let me stop right here. We have covered multiple aspects of building an Alexa skill with a code first and an IDE first approach. I hope that you learned the basics to start coding your next Alexa skill as a professional developer. Maybe a great next step for you would be to dig deeper into the SDK controls framework to explore what's possible. We are really excited to see you join the more than 700k Alexa developers in our community that have produced more than 100k skills already. If you like working from the IDE, please keep an eye on alexa.design/toolkit to learn about all the latest features. Thank you so much for making it to the end, and don't hesitate to reach out to us via our Twitter accounts. Happy coding, Alexa Devs!